Testing the latest R1 and Maclan speed controls using the Minipro Dyno. Now this R1 is the latest, it says ultra fast response version. I think it's rated at 200 amps, and this is the latest Maclan MMAX. I've got the boxes here to update them, and offline I got the latest software updates, firmware updates for the Maclan and the R1, so we can have a look to see if they need updating and what changes or improvements the updates are going to make. Also, using the Minipro Dyno, we're going to take a look at the R1 13.5 motor, which is kind of class leader, wins lots of meetings, and compare it initially to just the standard motor that I'm using. This is my motor I use to test all the speeders, a 13.5, and then later on I can test other motors and compare them to this one and see how to get the best performance out of them. Testing the R1, fully charged battery connected up to the 13.5 turn motor set for maximum blinky. We'll do a 10% throttle, 50% throttle, 100% throttle, then 100% brakes, and we record it on here. We start sequence test 1. You notice that at the 10% throttle it didn't actually move, which means that the minimum power is not sufficient. On some speedos you can adjust the minimum power. I'm not sure you can on this one, so it didn't actually move. And looking at the acceleration, which is the blue one, there's the 50%, so it had to basically go from 0 to there, then up to 100%, nearly 25,000. Then the brake time, the steeper the curve, the stronger the brakes. It's quite shallow. And this is the current pulse, maximum current pulse when it starts, it's off, and then another current pulse when it hits 100%, and the current drops away, and there's no current at all when it's on full brakes. The LiPo voltage, the green one, obviously drops a little bit when it hits power, and then drops another bit there when it hits power there, and a small step up when it hits the brakes. We look at the program, see if there are any updates on this that we can improve this result. Connecting the R1 program box up to the computer with a USB cable, opening the update tool program, make sure these are on green. It tells you the firmware version that's on the box. Well, I believe this 410205 is the latest one, but we can just check by pressing this update. 410205 is the latest one. We'll run it anyway, just showing how it works, and it runs on here, going up in percentages. Successful. So that was the program box. Now we need to check the speed control as well, so both the green ones up. Device interface, so we can click on ESC now, and it says 41.8107 raw BRCA EFRA approved firmware. There's also one called mod firmware with softening, Let's open the raw approved one. It says 107 and we'll run the update anyway. Already was 41.8.107, but it's just doing it again. And that's what you do. So we know we've got the latest. Looking at the R1 chart, which shows you the various parameters you can modify, trying to see if we can improve the performance. In blinky mode, full brakes, obviously 100% we have. Now brake frequency, I think we're already on one, which is supposed to be the strongest, so I'll check that out. Power level 12 is maximum. Drive frequency, now at 10% throttle we're not really getting any drive at all. Whether or not I can set it a bit lower, we'll try 2 kHz. And also the deadband, maybe at 10% the deadband's too wide and it still thinks it's in a deadband, so I could reduce the neutral deadband. Don't really want 0, we'll see if we can put it down to 3 after checking what it is at the moment. All this timing is off, so the other figures don't really help us. So I'll have a look at those 2 drive frequencies and the neutral band. Drive frequency, I'm thinking of putting that down to, should we put it down to the minimum, 2 kHz. Power level, brake frequency, now that is on the minimum already. Full brake 100%. Initial brake 0. The new deadband, neutral deadband, that. Well, I'm pressing the left button and it won't go below 6% for some reason. 9, 12. Well, that's weird. According to the chart, neutral deadband should go down to 0. I can't get it below 6 for some reason. The R1, we've adjusted the frequencies to the minimum, but we couldn't do anything about the low end power delivery, couldn't adjust the neutral down any further. So we just see if that putting the minimum frequencies makes any difference. Drive frequency throttle was, I think, 6 kHz originally. Now we set it to minimum, and you can see that the acceleration continues stronger as you hold the 50% throttle. It looks like it might keep going. That's not that important, because if you're holding partial throttle you'll adjust it to the speed you want, and the acceleration part here is the same, and up here reaches the same same revs, and the brakes were already on minimum frequency, and you can see it's made no difference at all. Looking at the current, that was the original current, and this is the next current with the lower frequency. The lower frequency draws more current, it's about 10 amps, but at 100% it seems to draw less current. Going to full extreme, we set the drive frequency to 64 kHz and the brake frequency we set it to 32 kHz. All the other things will remain the same. Drive frequency and brake frequencies both set to maximum. So looking at the graphs, let's just get rid of the current initially, and we can look at tests 1, 2 and 3. The high frequency one's going to be the green one. The original default one was the blue, and the brown was, so we get rid of the original one I think. We look at the brown one, which is the low frequency, and the green one is the high frequency. You can see still wouldn't move at 10%. At 50% throttle they both accelerate, and then there's a slight change here, and then up to the maximum frequency they go. And then the brakes, virtually no difference. If anything, the low frequency one is just fractionally better. What about the current? Let's have a look at that. We look at the current for the low frequency and the current for the high frequency. Well, these tiny fluctuations of pulse and of current are slightly less at high frequency, but the maximum peaks are higher at high frequency when it hits changes the throttle position, especially when it hits 100%. There's quite a pulse of current there, and the current remains higher at 100% power. So maybe that would imply that there's more power available at high frequency than at low, but at 50% throttle it seems to be slightly less. And at when the brakes are applied, there's no current. So really the frequency doesn't seem to make any difference at all. You might as well just set it at the default values. Testing the MMAX Maclan Speedo. First of all, we're going to test it with the old profile version 2.4, and then we're going to update it to the latest one and see if we can get any improvements. So we'll do a test with the Minipro Dyno first off in blinking mode with the best settings that we can find, and then we'll update it. Just run through a few settings to make sure that they're all correct. Brake strength 100%. Brake frequency, it's on 600 Hz, which is supposed to be the strongest. Brake curve, well, we want linear. Drag brake 0. Initial brake 0. Throttle frequency, again 1 kHz, that's the lowest, supposed to give the most power. Throttle punch 100%. Throttle curve linear. Deadband middle. Deadband middle, I think I'm going to go narrow, see if it can get a bit more power at the 10% throttle. Run sequence 1. Right, if we look at the acceleration curve, I just take off the current. You can see there's a tiny bit of movement at 10% throttle, and then it hit 50%, and if at 50% it's quite a massive, it kept on accelerating. It looked like if you'd held 50% you might have actually got to 100%. Then there was the 100% jump there, took it to maximum. We had the brakes, which break down here, lost brakes faded away about 1000 RPM. And then looking at the current, well, we've seen this before with the speed control. It does a lot of pulsing at intermediate frequencies. The currents are going up and down wildly to maintain intermediate speeds, so the average amp draw is quite high, about 20 amps. And then finally, when it hit 100%, you get a more linear drop off of the amps down to here about 12 or 13 amps. And when it hit brakes, the current drops to 0. Now I'm going to update the speedo to the latest firmware, and we'll see if it can make any difference to this. Linking to the computer for the update through a micro USB connection. We've also got the lead connecting to the speed control. We can have a look at Pro. This is version 1.3. We can take a look at ProLink update. On the screen it says device online ProLink A 1.3. We can try the firmware update and see what happens. It's got a version 1.9, which is a long way up from this one, isn't it? So we'll update, which it's doing along the green line there. And now it should be version 1.9. We're installing the latest speed control version. It's taken a little while. It says it resets everything back to default, so we're going to have to reprogram it to the dyno as well. We now have a link to the speed control, and we can do a speed control setup on here now as well. Now we can access all the parameters online. Up here we've got a profile which we want touring car blinky, and then we can see this 100% brakes. The general settings will be blinky mode, protection, well, you could take them off. Generally we will leave them on, that's not affecting us. Brake settings, as I said, we've got 100%. Throttle settings, 100% linear. Deadband, I prefer it on narrow. Save. And we'll test it now, see what the differences are. Testing the Maclan with the latest speed control firmware 3.0. The programmer is 1.9. Everything's on default and 100% power blinky mode, except for narrow neutral deadband. I take off some of these. Let's just take off the current first. That was the old Firmware, the blue one, and at 10% throttle it didn't really get going at all. Now, except for a very small bit of time for some reason where nothing happens, it now at 10% you can get quite a lot of rev, nearly up to 4,000. Then we've hit 50%, you get a proper curve here similar to other speedos, and then 100% goes up to maximum there. The program is just slightly offset. Brakes, supposed to be improved brakes, but as you can see the curve is really identical. Might be a tiny bit better just right at the very end. Looking at the current, now the original one, the current used to pulse badly at 50%. which would be the pink one. There are lots of pulses going on at 50% throttle. Now let's look at the new firmware. Much more normal compared to other speed controls. You've got the current is controlled now, and it's quite low current, about 10 amps. Before it was high current there, and then when it hits 50%, much less current being drawn and given a nice steep curve, no current drawn at brakes. So it's a huge improvement in performance on current control, and the bottom end you've got a nice control on the throttle as well. I'll try a couple of other settings like minimum frequency to see if it makes any difference, and I'll put the neutral bandwidth back to middle. Testing the Maclan with the frequency for the brake set to minimum, forward power set to 6 kHz, and the deadband I've put it back to middle. Here the green one, you can see you've got better control at 10% throttle now. It's only up to 3,000. Before with deadband less, it tended to jump quite high. The curves same, brakes the same, no matter what frequency I've tried. It doesn't seem to make any difference at all. So that's the Maclan, the latest version. Obviously an improvement on the earlier version, but on the acceleration curves, but not on the brakes. Didn't really make any difference at all to the strength. A comparison of 3 speed controls and the results of the test. I've got the R1 speed control, the top of the range one. I've got the Maclan RSX and the Maclan MMAX speed control. If I just take off some of these and then we can compare them, take off the voltages, we'll take off the currents and we'll look at the revs. So the amplifying, the blue one is the R1, the brown one is the Tekken, and the green one is the Maclan. Now at 10% throttle, the R1 we couldn't get any movement at all. So if you're trying to go very slow, approaching a grid position, it's a bit difficult. You might put 20% throttle and it might jump. The Tekken was very good low speed. We set it, you could adjust that on one of the parameter settings, the minimum throttle, so that's very nice. The Maclan, by setting the neutral width, if you put it at minimum or very, I forget what it's called, low, it jumped up quite a lot, the throttle. So putting it at the middle setting, except for the beginning where nothing seems to happen at first, then it gets up to there. Then they all hit 50% power, and you can see the steepness of the graphs all about the same, the lines as they accelerate. It's just that the Tekken seems to put a bit more power at 50% throttle than the others, but that's not important. It's where you shows that they do have a good acceleration here, all about the same. And then 100%, that's steepness of the curve is how quickly they're picking up. As you can see, they all go the same, and they all end up at the same revs about, but the Tekken just ahead. But the important thing is the brakes. At 100% brakes, the steeper the better. So the Tekken's a brown one. That's got very strong brakes with active brake set. The other two are almost identical. The R1 and the Maclan, their latest firmware software settings haven't increased the brakes in this test anyway. They both get down to about here a maximum 2000, 1000 as brakes are fading away, and you can see that the bottom end of the Tekken, although it's braked it down very fast, it fades away below 1000 week. Looking at the amps, we had the amps for the R1, the amps for the Maclan, and the amps for the Tekken. You can see that they all have similar amps. We take off the curve. They've all got similar. They pulse when it hits quite a high one there for the Tekken. Then they've got this pulsing effect, 50%, going down here to about under 10 amps. Then another pulse as it hits 100% throttle, they all pulse up. Then they all fade down almost identical. They're drawing at maximum revs, they're drawing about 12 or 13 amps. Then when you hit the full brakes, they all drop to 0, except after a second the Tekken, which has active brakes, starts applying probably reverse pulses. That's why you've got these a couple of current pulses here, which enables the brakes to be much stronger. I believe that's how they do it. We just put on the curve there, and you can look at the curve of one of the others. So that's the differences is that very little once you can set it down here, except for the R1, 10% throttle is not great. The new software for the Maclan has helped that a lot, but the brakes are still not good on the R1 and Maclan compared to something like the Tekken. Also the Hobby Wing and the LRPs have got strong brakes as well.